Yeah, so I've been off buying more crap off eBay. What we have here is um, a heating pad for animals. It's basically an electric blanket for your pets. Uh, with a rather nice, or not, Hello Kitty design on one side, and on the other side, oh, very sort of early 80s floral pattern, the sort of thing you would see from Laura Ashley. Um, really not very well made. And to be honest with you, I don't like electric blankets. It's one of those things that growing up in the UK in the early 80s, and even moving to Ireland, is still seeing the same things. There'd be public service announcements on TV, or as we call them, public information films, about how dangerous sleeping electric blankets could be and how you had to service them every year. And all I could one think as a child is, why do these even exist? You're pumping mains voltage through wires and then you're going and lying on top of it. That just doesn't seem like a good idea. And even if you're not actually keeping them switched on when you're sleeping in them, and you shouldn't, given the nature of them, that they bend, they flex a lot, there's a high potential for damage. A very odd thing to exist, if you ask me. Like, some people love them, some people swear by them. I personally think they're the most dodgiest product ever, one of the most dodgiest products ever made. But there you go. So anyway, let's have a look at this. Initial impressions are, of course, it's cheaply made crap. The power lead, which has an American plug on it, very thin, very flexible prongs. It's made out of a sort of plastic or rubber, which you don't expect to be used for something like an electric blanket, given that it's a resistive product. The whole point of this is to resist flow to generate heat. Generally expect more heavy duty wiring. So this is like really thin, it's cheap, it's nasty, it stretches. It actually stretches. I don't know if you can see that, but it's stretching a bit. Power switch, very cheap and lightweight. And it goes in here. It's all in Chinese. That's how it works. So let's say the first thing first is I'm going to test it and see what sort of power consumption it uses. They sent me one of these dodgy def laden adapters, which I really don't like. But there you go. So which is high and which is low? I don't know. So that looks like it's off. Huh. Oh, here we go. Took a few attempts to get that plugged in. See what what the meter's saying here. It's saying 10.6 watts. And the problem with these is because it's sitting in the open air, it's going to be hard to get it to warm up. So what I'm going to do is do a quick test first of all with the thermometer. So it's averaging in 24 degrees, sorry, 24 centigrade. So I'll leave that on top for a few minutes just to see how that changes things. .6. So curiosity, what happens if I see which is the highest one? Well, that takes it up to 21, so that must 21 watts. Take it down to the bottom, 40 watts, so this must be off. So there's two settings, low and high. See if we can get that into the shot there. So let's do a quick test. .8. So what I might do is take a little break and come back in 5 minutes to see if this heats up anymore. So let's do one quick check. So it's 25, 29, 27, 31, 30, 28, 26. It'll go up again. Yeah, 30. So I think the wires go up to about 30 degrees. So what's happening? Because there's no real padding or insulation in this to sort of collect the heat. Like So what's happening is the wires themselves are remaining pretty warm. There's one went up to 32. But as soon as you go off the wires, and the wires are about 1.5 or 3 centimeters apart in new money, the temperature drops off, but then hit the wire again, it goes up, so they're 31. Drops down, it'll come up again, drop down, and then it'll go up again. So there you go. So what's happening is the wires are heating up and not much else. And 31 degrees, well, I don't know if I'd call that decent. I don't use electric blankets, so how would I know? So anyway, let's start taking this thing apart and just see the real problems with this, because I suspect this is quite dangerous. So what I'm going to do is start off with the control box here. Got the right kind of screwdriver? Nope. Need a bigger one than that. Your screwdriver. Every screwdriver except the one I need. Let's try this one. Now modern sleeping electric blankets are actually, fairly advanced. In the old days, oh, that's nasty. What is that? 2 resistors. What's the code on them? This is cheap and nasty to the extreme. So actually, yes, after a bit of investigation, that's not a diode. It's first of all, it was a diode because I've seen diodes like that, but it's actually a capacitor. So they're actually using a capacitive dropper to reduce the voltage and the flow. So what's happening is, whenever you power it on, this is the off position. So that then literally, I don't know if you can make that out, the 2 legs here and here and here and here straddle this pad, and as you push it up 1 notch, it straddles that pad, and that pad. So there's a current flow this way and this way. And if you push it up to the next notch, it straddles that pad, and that pad, and that pad. And that pad goes through a so yeah, that pad is coming straight off the mains, and that one there is reduced by the capacitive dropper, if that makes sense. Oh yeah, so it's nasty. Not happy with that at all. But anyway, the quality of this construction is appalling. It's like, look at that soldering. And this board, this material here feels like some sort of cheap, nasty rubber. And it smells cheap and nasty too. The kind of smell you expect. So, let's put the screws to one side so I don't lose them. Let's go and have a look inside here. Oh yeah, I was talking about electric blankets earlier. I keep calling them sleeping blankets for some reason. The law is, well, not the law, but the way they're made nowadays is, instead of having mains voltage going through resistive wires, you actually have carbon fiber elements which can operate on 12 volts. And they also have, so you'll have your carbon fiber heating filament, but outside of that you'll have 2 extra layers. One will be the feedback layer, and that's basically a material that changes resistance based on heat. So back in your control box in the lead, you'll have a bit of circuitry that measures the resistance of the detection wire, and if the resistance goes up or down beyond a certain level, depending on the configuration, they'll know that the filaments have overheated and to shut down. So it's a very safe way of doing things. But then there's also the issue of you're still putting electricity for your bed. So let's see how this is fitted on. Oh, they just tied a knot in there to get it in. So how is that attached on? I can't believe that is literally the wire coming in from here. It's the same kind of wire. On focus camera. So literally the wire that comes up here goes straight into the blanket. There's no joint here. I was expecting to see some sort of junction here or some sort of soldering. But that wire is Well, you know what that means? That this too is part of the resistive circuit. This lead here. Which is not what you want. You don't want this heating up. Because this is cheap and nasty. And could melt if there was too much current going through this. Yeah, I honestly wouldn't let my dog sleep on this. It'd be too dangerous. The risk of electrocution if he wet the bed. Well, no, he's a dog. He's well trained, but you never know. There's absolutely no overheat protection circuitry at all. And this whole thing here just looks terrible. Plus the fact that the whole thing is just one big massive resistor which could overheat and burst into flames. So there you go. It's not safe. So what do you expect for something that costs $2.54? Yeah. But you knew that anyway. Cheers. Bye-bye.